Here's the story of how I ported my N64 game to PC. What started out as what I thought would be a simple port of my N64 game Telelocation to PC ended up taking longer than the original game took. This was partially self-inflicted because I decided to add online co-op. Telelocation Gemini was the first real N64 game I made.
I made it for the first N64 Brew Game Jam about 4 years ago in a team with 2 other people, and it ended up taking first place. The Game Jam was for 2 months, and the theme was size, so our take on it was you have 2 characters of different size, and they each have their own unique abilities, and you need to use them together to solve puzzles.
That little guy is called Commander Smaldron. He moves faster, and he can jump. Oh crap, the big one, what's the big one called? Oh, Megalazar. Did I spell that wrong on the box? Oh, Megalazar is the bigger one. He's a robot that you find on this planet, and he moves slower, but he can blow up rocks, and you can use him as a platform. This game is playable by yourself. You can switch between the 2 characters when on a single controller, but I also added a coop mode. Co-op. I meant co-op. In the co-op mode, you have 2 players, each with their own control, and each control a character on a split screen. While split screen works great for N64, I think it's one of the awesome things about the console. When porting to PC, I figured games these days people expect to be able to play online. So I decided to add online co mode. Co-op. Co-op. Co-op ended up being a lot more work than I expected. Before writing any network code, I had to decide, am I going to use UDP or TCP, which are just 2 ways computers talk to each other over the internet. And I spent some time going back and forth on this choice. TCP handles dropped packets, so I don't need to resend data manually. But UDP has the potential for lower latency, which is important for games. On the other hand, TCP ensures that data arrives in the same order it was sent. UDP has no such guarantee. But peer-to-peer connections are easier with UDP, which would save on server costs. TCP does automatically throttle slow connections, but my game really only needs about 8 kilobits per second. I could play over dial-up, so is throttling even necessary? Although TCP does manage the connection for me, but then I'd need to worry about reconnecting the socket if it decides to disconnect. UDP just sends the data, no connection needed, so I can implement connection management however I want. Trick or treat. No, I'm not too old for this. Yeah, I know it's the middle of April. I'm Link from Zelda. Okay, yeah, let's go with UDP. It'll be a good learning experience, and is pretty much the standard for online games anyway. There are many strategies for doing online multiplayer, but I decided to just go with the strategy of having each computer send the input to each other, and they can both simulate the same game in lockstep, given that they have both the same input. So just one frame after another, they get the same inputs, and they simulate the exact same thing to stay in sync. One really important thing you need to do if you want this for your game is your game needs to be deterministic. So that means that given the same inputs, you get the exact same outputs every single time. So I added this determinism by 1, I fixed my time step. And that just means that when I do a physics update and a simulation update, it uses the exact same time interval every single time, instead of trying to determine the amount of time that's passed and only simulate that. I fixed it to about 1/60th of a second, so I'm targeting 60 frames per second for this. And then I ensured that my update logic always happened in the same order, and made sure there's no sort of global state that was hidden that affected the simulation, and no randomness. That'd be a big one. If you have random number generators, you have to make sure that they reset to the starting seed every single time. The next problem is that there are delays when computers talk to each other, especially over the internet. There are 2 things that I do to help solve this problem of needing to wait for user input. And this is actually based on a GDC talk called Rollback Networking in Mortal Kombat and Injustice 2. The first thing I do is I also delay the input on the computer that is generating it. So that way you have about 100 milliseconds for the input to arrive, and when it does, you play back the peer user input and your own after that given delay. So that way, so long as your connection is less than 100 milliseconds in latency, then you don't see any problems with networking. But 100 milliseconds really isn't enough to prevent pauses on a really bad connection. If packets are taking more than 100 milliseconds to arrive, or you have a few bad packets here and there, you don't want the game to pause while it waits for that input. So what I did, I actually just saved the state of the game every single frame. So a location of the players, any platforms, anything. The entire game state needs to be saved off into memory. And then if you get to the point where you don't have the peer user input yet, but you need to simulate a frame, you just simulate it anyway. And you move along, simulating with the incorrect input. But once that user input arrives, you load the state that you saved from the frame where you were last in sync, and then you replay those frames, but now with the correct user input. And that replay happens all in a single frame. So the player is just gonna maybe see the person they're playing with jump around a little bit. But the important thing is that my experience of controlling my character on my computer is smooth. So it continues to move with no issues. But there still is a limit to how long I let the game run without peer input. It takes about a second. So if you get a disconnect for a second or more, then the game will pause and wait for a reconnect. So just implement those two things, determinism and this rollback feature, and you can get two computers playing the same game and have sync issues. Wait. Okay. So you fix the sync issue, and now you have another sync issue. Fix that, and then weird. Okay, look at that. That was just a serialization bug. Okay, it seems pretty solid now. I think I got it. Nope. Another sync issue. Okay. All right. After a lot of testing and trial and error and fixing bugs, I got it. I think it wasn't the last bug. And I spent weeks trying to figure out what was going on. I eventually had to write code that saved all of the inputs that was being received into a file, both from the player and over the network, so I could precisely reconstruct what was going on when these desyncs happened in multiplayer. After weeks of searching, I found this. What you see here, this is the old code, and this is the new code. I was storing the robot's new location after restoring from a previous state into a temporary variable that just disappeared after this function call. So I was basically doing nothing on this line. So this properly put back the robot's position in the collision code, so that way the next frame collision happened properly. Thought I was done. Still another bug. This time I just need to do sort the colliders, so the collisions always happen in the same order. That one was fixed. And then after that, there was one last bug. Long story short, inputs from 2 levels prior were leaking into the current level. The solution is pretty straightforward. I just clear the input stream at the end of the current level. I was clearing it at the beginning before. You don't need to know the details as to why that mattered. Just know that clearing it at the end fixed it, and now we're back on track. Yeah, the thing about these determinism bugs is they can be kind of hard to reproduce. Sometimes it just works, and you're like, oh great, I think I got it working. But there's a right weird corner case where something happens in a slightly different order, and you get syncing issues. So, I just want to talk briefly about kind of why I decided to do online multiplayer this way, because there are lots of ways to do it. If I was making a game that had a lot of players, I probably would have a dedicated host who is responsible for simulating the game state and then distributing that state back out to all the peers. That way there's a single authoritative state. If a single person has a bad connection, then the host can continue simulating, and that one bad connection won't really affect everybody else. Because as you add more and more connections, this peer-to-peer model, has issues. If one person has a bad connection, you don't want to pause everybody. Although if the host has a bad connection, well, then everybody's going to feel it. So you could just move that to a dedicated server. And so now the server is the one simulating the game state, and everybody just sends their inputs to that and then gets back the information about what happened. But I didn't really think I need to go that far to try to simulate game state on a server. I don't have to worry about people trying to do hacks like seeing through walls. So like if every computer had a full copy of the game state and you tried to hide things from the player visually, but it was in the computer, Then you can add hacks to see through walls or things that give the player information that they shouldn't have. So the server can do things like, well, I'm only going to send you information that you should have access to. And that kind of helps defeat some of those hacks. But my game wasn't online competitive multiplayer. So I figure I'm probably okay just keeping it simple. It lets me write a very simple server. The server is basically just a lobby with a game matching system, and then once you get 2 players in the same game, you try to establish a direct connection between the 2, and if you can't, then the server can act as a proxy to route traffic between the peers. And there's actually 2 good advantages for the direct connection. 1, saves me server costs, but 2, it's actually a faster connection. If you have 2 people on the internet, they can establish a direct connection to each other. That's a lot less latency than getting a third computer involved that has to route all the traffic through. The server is really quite simple. I'm only running on a single thread. If I do have performance problems, I could spin up additional threads to handle the routing of packets between peers when they can't establish a direct connection. Despite being single threaded, I can still host. Let's try that again. 120 games concurrently. And look, I know 120 doesn't seem like a whole lot, but let me show you my server. Yeah, that guy right there. That thing's like 8 years old. Yeah, it's not a lot of power, but I think it's more than enough for what I need. So, back to you, Weather James. And one reason I'm able to keep it on a single thread is because I ended up going with UDP over TCP. So with my server up and running, I wrapped up a few more bugs, added a few extra features like a controls mapping menu, and with that, the PC port is done. I learned a lot, which was my biggest goal. I plan on releasing my current N64 game project on PC as well, but in order to kind of figure out how that would go, I wanted to do this as a proof of concept. If you want to follow that game's progress, be sure to subscribe. Also, Patreon supporters have access to the game right now, so if you go sign up, you can go download the game, any tier, and you can get it. I'll also post access to the source code if you're interested in that on the Patreon page. If you don't want to become a member, but you still want to buy the game, I'll also link it in the description. Thank you all to my Patreon supporters. Your support of the channel is really greatly appreciated. So, thank you all for watching, and until next time, take care. It's a co-op coop coup! Okay, that's probably good.